All right, done yet? Just do the first times derivative of the second plus the second times derivative of the first. Just do that. Mr. Fowler, I'm glad to see you, sir.
Likewise.
And yes, you will use trig identities. I would rewrite the problem first. Maybe something like this. That might help you a little bit because that's a whole lot easier to work with than that. And that's the derivative of that, isn't it? Well, not cosine squared, but what's the derivative of cosine? Sine. Or the negative sign. So now you're looking for that fourth bowl. The reason this is a good problem for a test is because it kind of gives you a reason for doing these type problems, because you can actually see to take a problem and just rewrite it, manipulate it so you can get the answer. Nobody's ever going to walk up to you and ask you what the antiderivative sign is. Sine. Nobody's going to ever ask you that. But people will ask you to look at a problem and break it down several different ways, whether it's a bridge or whether it's a research problem or whether it's a finance problem. And you can either break it down into several different parts or you can tell them you quit. How can you rewrite the sine squared? And I would put that in parentheses. And then I would put this in parentheses. Why do you want to keep this together right here? Why do you want to keep that together? Because it's u du. And if you could make this go across this, then you would have u du minus u du, some kind of form of u du. And that's what you want in a lot of these problems. You want to find some kind of u du pattern to it. That's what you want to find.
Now what could I do now?
You can distribute
Distribute what?
the, one of cosine is.
I would distribute this. No, distribute one or the other, it doesn't matter. And that would give you the antiderivative of cosine squared sine x minus cosine to the fourth x sine of x dx. Finish it out. Now, if u is equal to the cosine, du is equal to the what? Negative sign? We don't have a negative sign, so that means you've got to what?
Multiply by
Huh? Put a negative out front. So don't forget to do that. So break it up. In fact, I'll just take this to the next page. And we'll get the antiderivative, cosine squared of x, sine of x, dx, minus the antiderivative of cosine fourth of x, sine of x, dx. So if I make u equal to the cosine of x, then du is equal to the negative sine of x. And that's going to be the same for both. So what is that going to put out in front of here? It's going to put a negative. And that's going to make this a what? Positive. And then you'll have negative antiderivative of u squared du plus antiderivative of u to the fourth du. And that'll give you negative u to the third over 3 plus u to the fifth over 5 plus c, and u is what? Cosine cubed x over 3 plus cosine fifth x over 5 plus what? Now you can bring the 1/3 out, you can do that, and the 1/5, that's fine. Manipulation with a capital M. See if I can find one in your book. Where I got that one, probably out of the old book. Okay. Alright, this time y'all do cosine squared tangent cubed. Cosine squared tangent cubed. It's number 17 in your book. Let's see if I can snip it like y'all taught me how to do it. Let's see, 17. Gotta find the page turner. Where is it? I appreciate the heck out of that. That saved me a lot of time. Who showed me that? Huh?
Those guys.
Well, y'all gonna give y'all extra A. Good thing.
I really confused it.
Let's see if I can muster up some bonus points somewhere. Downloads. I used it all day yesterday. Cosine squared of x, tangent cubed. Now this one I would probably use your reciprocal identities. Do y'all remember in trig when the teacher was supposed to tell you, hopefully they did, that whenever you can, try to get everything in terms of sine and cosine? You remember that?
Yeah.
Well, that still holds true.
pull this off again. I'm just gonna just start snipping the whole class. That's what I would use.
It really has changed your life.
It has.
It hasn't.
It really has. See, I didn't know I could do that. And it helps y'all too, because y'all don't have to remember as much. Now, if you want to go backwards, then change the cosine to 1 over secant. Now, that would be going backwards. That would be tightening the bolts on your starter instead of what? Loosening them.
But if you,
Or breaking them off
yeah,
into
if you're
the
breaking the
block. Yeah,
yeah,
that would be going backwards.
but if you break the head off, you can take the starter out.
You could pull the starter out, but then you have to weld nuts onto the...
But you can still do it. But
and you know that weld ain't gonna hold.
I don't know. I've got some sketchy welds on some suspension components.
Listen, I have to. We had the rock guards and the roller bolts on the D6 on the farm, just shear off, and they were sheared off flush with the track.
Yeah.
And I had to get under there, this far from the ground. I had to cut the rods and take a 15/16 bolt and hold it with a pair of vice grips and put it right there and weld it to the bolt. It took me about 3 or 4 weeks to get all them bolts out. I got about 12 out. To this day, every other time I run that D6, I make sure the bolts are tight so they don't shear off. Because I don't want it. If I have to do that again, I'm going to sell the dozer. I'm not doing it again. So what could we change that tangent to?
Sine or cosine.
Yep. You could also, yeah, sine or cosine would be the best one. Then see what you get. So, dang old antiderivative of the cosine squared of x over 1 times, and we'll change that tangent to sine cubed over what? Cosine cubed. And that's going to give us the antiderivative of cosine squared x sine cubed x over cosine cubed x dx. And dang old, what happens to the cosines? Cancel. And you get the antiderivative of the sine cube of x over the cosine of x dx. Dang old, what is that? Y'all supposed to be saying something that's not rhetorical. Just forget about the cube. Forget about that. No, sine over cosine. You got to take the integration. You got to do the antiderivative. So you're looking for what pattern? I said it a while ago. You du. Now you gotta look for some kind of pattern of u du. What do you see?
Well, if you
Huh?
take,
The fu.
no, if you take the UV sine, then you get the cosine would be your du,
So what do you have? You have,
u over d,
and what is that?
not a lot.
Huh?
I mean, you can't solve it when it's the 1 over cosine of x.
Keep doing what you were thinking before that. Du over u over du, du over u. That rings a bell. U over du, or du over u. Which one is it? What is that?
This is a flip.
That's it, huh?
This is a flip. You would have u over u.
Well, keep going with that. You're gonna keep going with it. You're getting there.
What I did, I just took the sine and multiplied by sine squared x and did the identity times squared x.
You took what now?
I kind of took the sine x times sine squared x and substitute sine squared x for 1 minus cosine squared x.
Yeah, you could do that. That would work. I think it would, yeah. Finish it out. Natural log is in the answer. You could, are you talking about changing the sine cubed into sine squared times sine? Is that what you just said? Yeah. That would work. Just like you did in the previous, but you've got some form of u du going is what I'm trying to get across to you. And that's what you want to get. So I would change what, 1 minus the cosine? The sine squared is 1 minus the cosine? And then work it out. So this is going to give you the antiderivative of sine squared of x times sine of x over cosine of x. I don't know why I'm wanting to write the x up in the exponent. Dx. And sine squared of x is 1 minus the cosine whatever. So we could rewrite this as 1 minus the cosine. So antiderivative of 1 minus cosine squared of x times sine of x over cosine of x dx.
You distribute your sine.
Distribute the sine. Sine of x minus sine cosine squared of x over cosine of x. And now you can put it over the common denominator. I didn't give up on it. I just do whatever it copies. And that's going to give you the antiderivative of the sine of x over the cosine of x minus the antiderivative dx minus the antiderivative of the cosine squared of x, sine of x, dx, over cosine of x. And you can take these two, and what can you do here? That's a square, you can't read it. Antiderivative of the sine of x over cosine of x dx minus, and what happens here? You get cosine of x times what? Sine of x dx. Make sure I haven't made a mistake. I hate it when it does that. Switches the buttons on. Now what do you have? Set u equal to the cosine, and if u is equal to the cosine of x, what's du? The negative, equals negative sine of x. So we know, again, we need to take our red marker, and that'll put a negative out here, and a positive here. And here we have du over u plus the antiderivative of u du. And what is this? Negative natural log of u plus, what is this? U squared over 2 plus c. And now u is equal to the cosine, negative natural log of the cosine of x plus cosine squared of x over 2 plus c. Manipulation, rewriting. Let's try this one. Everybody got that one? You feel good about yourself? Feel confident? Y'all don't lie, do you? Antiderivative from pi over 6, pi over 3. I don't want y'all to forget the tedious mathematics. Of cosine cubed of x over what's the first thing you're going to do?
Take the top, take cosine cubed, turn it into cosine of x times cosine squared of x.
Well, before you do any rewriting, what should you do with that radical? Change it into an exponent and bring it upstairs. Because that way you'll have u du. And then do what you're talking about doing. gonna change, like you said, the cosine to cosine squared times cosine. These are kind of like what? Puzzles. So if you suck at puzzles, chances are you're gonna suck at these. Trying to discourage you a little bit more.
Not drop by Friday.
Of course, yeah. Always. If there's any question, you know I'm kidding. I don't think you should drop it unless you just have no earthly idea what we're doing. If you have no earthly idea what we're doing, then don't answer that question because that'll hurt my feelings, and then I'll have to go put smokestacks on my truck because then I'll be very insecure about myself.
I like how that, I like the direction that one.
People ask me why I put a brush guard on my truck. I don't know if you noticed, but I put a brush guard on it.
I'll tell you why I put a brush guard on.
Let me tell you why I did first. A lot of people say, you're going through midlife crisis, you're going four-wheeling. No, it has nothing to do with the woods. Anybody have any clue why I got a brush guard on the front of my truck?
I don't know why you got a brush guard, but I know why I got one.
Will you be quiet? The headlights on my truck are what? Plastic. So they break real easy. And when you go and check cows, the cows sometimes don't move. And what happens when a piece of plastic runs up against 1,200 pounds and 1,200 pounds don't move real fast?
It'll probably crack.
I've cracked 3 or 4 headlights and I get tired of buying them. So, because then they fill up with water and moisture and then eventually make your headlamp bulb bust. Now, why did you put a brush guard? Because we know you don't want to tell us.
Instead of cows, Explorers don't move. Now I creamed the rear end of an Explorer over the summer, and the only reason most of the front clip is still intact was